So I recently showed you guys some of the issues regarding Battlefield 6 and anti-cheat and how on X3D CPUs or core parking CPUs, it doesn't behave as intended for the CPU. Well, a viewer of mine who's a developer actually said, hey, I've got a tool that actually works pretty well. And it is, in his opinion, and I'm kind of agreeing now that I've been messing with it, better than Process Lasso for a couple of reasons. One, Process Lasso's got probably a lot more information than you really need. And two, it's free. Not Process Lasso, but Core Setter. Today's video is brought to you by our brand new GPU Apocalypse 2.0 shirt, kind of immortalizing all of the stuff you love about today's GPUs. Our GPU Apocalypse 1.0 shirt was actually one of our most famous and popular shirts, and now it's re-immortalized with GPU 2.0. But let's face it, the Apocalypse never went anywhere, it just evolved. Just like this shirt. Go buy it now. So Core Setter is a free utility you can download on GitHub. It's gonna probably look a little different when you get it versus today, because I've been kind of giving him some feedback and he's making some tweaks and changes. The code and everything is up there. If you guys aren't aware, GitHub is like a repository for developers to share their projects and stuff. And that's why a lot of projects that end up open source end up on GitHub. So I gotta preface this with, this is a single guy, this is not a company. I can't vouch for anything beyond I've tested it so far and it seems to do what it's supposed to do. And so we finally were able to park cores, or at least not park cores as much as limit the threads and cores that Battlefield 6 is able to actually access to keep it all on the cache die. So today we're gonna talk about whether or not that gives us any performance lift, but I'm gonna show you in real time how it actually works. So Core Setter has a pretty basic UI that looks like this. And essentially, it is nothing more than the process that is running, the percentage of CPU that it's using on average, and the creation date. I guess that would be the uptime. That's actually, yeah, that'd be the uptime. And then you can see right here, you've got CPU set, and you see one of them says cache. Now, if you go to the settings tab right here, this is where you can add and remove different sets. So Freak, we'll call it Freak for frequency. And now you can see as soon as we make a new set, this is one of the changes I suggested that he make, is that he labeled these CCD0 and CCD1 or cache or Freak, or because the 9950X and the 9900X are not cache and frequency cores or CCDs. They're just CCD0 and CCD1 because they're what's the word where they're the same? They're identical, synonymous, whatever.
Homogeneous?
Yeah, they're not different in terms of clock frequencies and cache availability and all that sort of stuff. So what I'll do here is I've got one set to frequency. Now this is kind of neat because you can do sort of the opposite of core parking, where with AMD's core parking logic and using the game mode built into Windows, the whole point is to identify a game and put it on the cache die and then park the other one. The problem with parking the other die is unless a process starts to become heavily accessing the CPU, the cache die becomes responsible for all of the background tasks as well. So essentially you cut your CPU in half through software, and then all of the random background tasks happen on the cache die, which could have some impact in performance. The inverse of this would be if you take something and you want it to only access the frequency die. So the cool thing about Core Setter is that you could do that. Let's say, for instance, you have a particular game. See, here's the thing. Cache doesn't benefit all games. Not all games will benefit from a high cache. Some games benefit from frequency. Now the problem is you can't really park it the other direction, or you can't set it to the other direction because it's set to only put games on the cache die. So if you were have a particular game that you know benefits from frequency, maybe, I don't know, Civilization or something like that. I just throwing that out there, I don't know. There are games I know for a fact though that benefit from it. You could set those to run on the frequency die only, and then the cache die can handle all of the background tasks and stuff. But here's the cool part. You can also make it so that the game doesn't use all of the threads within the CCD either. That's not something that the Xbox game mode or game bar or the driver for the 3D cache optimizer is able to do. It just lets that task handle or have all of the threads available on that CCD. But the cool thing is some games might benefit from a little bit less available cores to it. Let me give you an example. If we know for a fact that there are certain tasks that are being handled on the cache die as well, you could limit how many of those cache cores are available to that task, and then have a couple left over to handle maybe other background tasks within that particular die. There's a million different use cases this could be. A lot of these are going to be outliers, but the cool thing is this is a very easy to use utility that lets you take over full control over your AMD CPU, even better in my opinion than Process Lasso. And that's not just because of the fact that it's free, it's also extremely lightweight, it's extremely simple and intuitive to use. Where Process Lasso, you look at something like this and a lot of people get really freaked out like, oh man, I don't know what all this means, this is scary. What is priority class? What is GPU priority, affinity, and the rules and all that kind of crap, right? So the only reason why I have Process Lasso up right now is I think it has a pretty nice GUI here on showing what the cores activity are. That'd be one suggestion I have if the developer, his name's Simon, sorry if you didn't want your name out there, but hi. Anyway, I think it'd be neat if he had a visualizer on here so you could see what's happening with the threads as well. Otherwise, you would have to just pull up the advanced overlay in the GPU settings, advanced GPU settings within Windows, and then it can actually show how many threads are being utilized with a number. But I like a visualizer on a bar graph like that. So if he had a way to build one of those in, that'd be pretty awesome. Okay, so I'm in Battlefield 6. You can see by looking at the affinity there, the bottom row, which is the frequency die, is more loaded up than the top die. In terms of resolution, we're at 4K, and then we have VSync and everything off. So I just showed you we are running the game primarily on the frequency die, but all of the CPU is available to the game. We already showed you how Process Lasso, others have gotten it to work, but I was not able to get it to, even after restarts of the game and such, could not get it to only go to the cache die. It just seemed to ignore it. So we assumed that was due to the anti-cheat. But what I'm gonna do right now is I'm gonna go to one of my community experiences that I made for testing this sort of stuff, so I potentially don't get blocked or banned, if you will, because I'm messing with this crap in real time. I don't want it to think I'm tampering with it. Anyway, I'm loading up the experience right now, and you can see right here in Battlefield 6, in terms of CPU setter, it is at, it's just normal logic. It's not letting, the program's not doing anything. It just has access to all 32 threads of the CPU. Now check this out. Let's go into the game. Okay, so here we are right here, just sitting static. We are on all of the core right now, or both cores. It's not doing any parking. We're getting 155, 154, 155. It's pretty steady. So here's what we're gonna do right now. We are going to go over to here, and we are now going to set it to just the cache. Now watch what happens on the right. Boom. Check that out. So we're able to actually park it over there, and our FPS, as you can see, is unchanged. Now check this out. If I go to frequency die, watch everything switch. Boop. It removed the game, and the FPS is. So it really doesn't seem to care whether it's on the cache or the frequency or all of them. And so maybe this is one of those games where the developers and AMD have figured out like, hey, it's not benefiting it to park it. So let's just let the entire CPU do its thing. Now this is interesting because the developer said through his testing, he saw slightly better performance by even limiting the threads even more. So what I mean by that is I'll go over here to settings, we'll go to cache, and let's just go ahead and uncheck a couple of them. Now look, I can literally limit how many threads it can see. You see how we have 2 blank ones now? I can drop this down even more. Look at that, in real time, just stripping away threads. But look, the FPS, we lost what? 3 FPS, just add one back, 155, add one back, 155, 156, add one back, 157, 156. Oh, I was AFK too long. What happens if we just give it 1 core with SMT? 40 FPS. The 4090 probably went full idle at this point. 28 FPS. 42, 72, 84, 105, So that's a 6 thread right there, 3-core, 6 thread. Now we're 4-core, 8 thread. See, we're almost to the FPS we were at 4-core, 8 thread. So it shows how efficient the game actually is, kind of. But I'm kind of surprised that they still want the entire CPU. See, like as soon as I went back to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a 5-core, 10 thread, we're at almost exactly the FPS we were. Now what he was saying he likes to do is leave 15 threads, AFK again. So what he likes to do is leave 15 threads to the game. That way one thread is still available on the cache die to handle other things. He's not saying that's why, I'm assuming though, because of the fact that if it does spin up something that hits the cache die, there's a thread available to it outside of the game. Now let's talk about this real quick. Even though we may not have seen a benefit to FPS by going from frequency die to cache die, it doesn't mean there's not a benefit to potentially doing it, because as long as the thread or the world thread is not handing off, that executable is not handing off between the two CCDs, you would have improved latency. Latency is what matters, right? FPS is one thing, latency is another. It's why like frame gen is such a controversial topic, because you get more frames, they're interpolated, but you get more frames, but you get heavily increased latency, because depending on the multiplier of your frame gen, that's how many frames, like the base frames are the only thing your input's based on. So if you click you click shoot on that frame, it's gonna have the interpolated frames and then the next frame before it will it'll register another input from you. So if you can keep the game on a single CCD, in this case the cache CCD, I would imagine that it's going to be an overall better experience. That way you're not having cross latency between the two CCDs, especially when it's handing off from one CCD that has way more cache than the other. But I don't believe this is one of those titles that's going to benefit FPS-wise heavily from being specifically on the cache. Now, here's the cool thing about this though. You might be looking at this going, well, if it doesn't matter, why are we talking about this? Because it's about taking control over your system, having more control over it, so you can have other tasks going in the background. Let's say you've got something, I can't think of a specific scenario, but let's say you have something else running in the background. You can force that other thing, let's say, I don't know, bitsum, so that's this, that's process lasso, right? That's the agent. Let's say I want to put that only on the frequency die, right? I can now make sure that process stays off of the other die. Or you don't have to do entire sets. I could just say, let's call this dual core freak. And I can add that. And then I can make that literally be, I think a copy or control select would be nice, but I can now say, I'm only letting 2 cores, in this instance 4 threads, handle dual core freak. And you could now, like, you can change which CPUs or threads those are utilizing. So you could truly map out your CPU if you want to. I think for most average users, that's not something they need to do, honestly. The process, this is the point of the scheduler built into Windows, and that's why Windows also will utilize GPU-assisted scheduling as well, because it's logic. It has to be able to determine what's the best place to put these particular tasks. One thing that's not starred on here, which would be nice if you could utilize this as well, especially on the AMD CPUs, is Ryzen Master will show you best core and second best core per CCD. It'd be nice to see those mapped on here as well. That way, if it's something you want to have always running on the core that's got the higher frequency available to it, because you'll have different frequencies within the CCD as well, based on best core, second best core. It'd be nice to be able to map that. But if you wanted to truly just start playing around with your CPU and mapping things out and keeping things truly segregated and separated from each other, you could do that with this tool. This is not doing anything custom in the sense that it's just simply a GUI that then does a registry edit, as far as I can tell, to tell the program which CPU threads are available to it. So I thought it was a pretty neat tool. This is why I think we have such an awesome community. So many of you develop really cool things like fan control. Remember when we found that one? No, guys, it's not a virus. It's WinRing 0. We'll talk about that soon. And it's been talked about to death, but people still message me going, you said this was a good thing and Windows said it's a virus. It's like, no, it's just the WinRing 0 platform of which a lot of it was based on. And I think they've even modified that now, so it's not even WinRing 0 anymore. So anyway, guys, I'm gonna get on out of here. I just wanted to share this tool with you. I'll put a link to the GitHub down below. Like I said, it might look a little different than this because I was giving him feedback and he's already made some of those changes in the time that I started this versus when we're filming it. Things I think I'd like to see though, And I believe the new version already includes a CCD1 or 0 CCD1, so it's identified which is cache and which is frequency, because people may not know just by glancing at it. Putting stars and symbols somehow next to the 2 best cores per each CCD, and then some sort of a visualizer of usage. That way people can kind of just know by looking at it whether or not things are parking and moving like they're supposed to. Like I use Process Lasso to demonstrate that over here because it's got this built in, but I'm gonna go ahead and turn off Battlefield 6. There we go, let it have everything back to the normal behavior. But yeah, I think stuff like this is awesome. I love to see the things that my community comes up with. But all right, guys, thanks for watching. Battlefield 6 itself, in terms of FPS, didn't really see an improvement of parking the process on one cache die, but doesn't mean the latency wouldn't have been improved. I just don't have a way to really measure the latency. I don't have the right tools for that. But all right, guys, thanks for watching. As always, we'll see you in the next one.